All right. So, till the last week, we were kind of working on learning volume, surface area for different types of shapes. Some basic shapes, some compound shapes, or compound objects rather. And then now we are moving from volume surface area towards advanced trigonometry. So again, when I say advanced trigonometry, we'll not jump onto advanced trigonometry from day one. We'll start with basic trigonometry and then we'll move on to the advanced part of it. So, hello Kushi. Hi Vishwa. Okay, so we are starting with basic trigonometry first. We'll talk about certain concepts. So let me quickly call out the things that we wanted to cover this week. So we'll start with Pythagorean theorem and then look at Pythagorean triplets or triples. Then we'll look at basic trigonometric ratios and then we'll wrap our head around what are the sine and cosine complementary angles and their relationships. Okay. So anybody having any doubt or any question with respect to what we want to start with? Everybody okay? Okay. So let's get started. And I'm assuming everybody is able to hear me okay and see the board completely. And my request to each one of you would be that don't hesitate to ask questions, because I keep on confusing kids, sometimes on purpose as well. So just to make sure that we are following the same path and there is nothing cryptic or confusing to you guys, ask questions, okay? That's the best way to learn in the class. So let's start with Pythagorean theorem. And some of you will start questioning me, saying why Pythagorean theorem? This is something that we have learned in probably 7th grade. Yeah. So anybody who wants to tell me what is Pythagorean theorem? Even if that question sounds lame. Anybody? Yeah, go ahead, Shreyan.
Isn't it like a squared plus b squared equals c squared?
Okay. And what is a, b, and c?
They're like the sides on the right triangle. Like the C is like the hypotenuse. I think like, and then A and like B are just like the other like sides like that are like making the right equal.
Okay. Does everybody agree to what Shreyan said?
Yeah.
Yeah? Okay, wonderful. So let me just break it down for you guys one last time. And I would be doing a lot of copy paste based on what Shreyan said and what you guys agreed for. So Pythagorean theorem is given or derived for right angle triangle or right triangle, whatever you call it, where when I say right angle, I'm talking about one angle being 90 degree and these are the two sides between which the angle of 90 degrees formed. Hi Vishal. Hey, come on in. Find a place. You are late but not very late. So you have not missed anything. And be a little careful with those light tables. It can flip if you're not being careful.
Yeah.
Alright. So we are talking about the Pythagorean theorem. Something bothering?
What's this now?
That sound is to keep the insects and the rodents away. So this is that sound coming from this machine. But it should not be bothering you, right? It's not supposed to bother human beings. Okay. Ananya, are you able to hear me okay, beta? I see you dropped a couple of times and then joined back. So I'm hoping there is no network glitch at my end. So coming back to Pythagorean theorem. Pythagorean theorem says that this is a concept that is relevant for a right angle triangle, meaning a triangle which has one angle is 90 degree or right angle. And what this Pythagorean theorem says is a squared plus b squared equal to c squared, where c is the hypotenuse or the side opposite to the 90-degree angle. So this is the relationship that describes the Pythagorean theorem. Yeah, where a and b are the two sides which is making 90 degree, and sum of the squares of the sides is equal to square of the hypotenuse. Everybody is already very clear about it. I'm just trying to be redundant and waste a couple of minutes of your life. Okay? Is everybody okay with that? Now, this is a theorem given by somebody. And you guys will have all possible reasons to say why this is to be believed. Can anybody tell me how is this theorem derived? Any questions? Any feedback? I mean, Pythagoras was a great guy. He gave a theorem, and we are all believing it. But why? Math is a subject that is not supposed to be believed blindly. Okay? So I'm asking you guys, can you tell me how this theorem is derived, and why do we believe this one even? This is Pythagorean theorem I'm talking about. Anybody?
Hi.
I don't-
Sound wasn't working.
Okay, is it working now, beta?
Yeah.
Okay, wonderful. So I have $1 million question for everybody, and nobody gets $1 million. I'm saying this is the Pythagorean theorem. Everybody knows this is a right angle triangle where A and B are the two sides making 90 degree, and the Pythagorean theorem says a square plus b square equal to c square. One last time, anybody? What is the base of it? Why should I believe Mr. Pythagoras? I have never met him before. Yes, Jenna.
I think we should believe in this because they all relate to each other somehow, some way. Like, say even if we're trying to find b square or something, then you c square minus a square, and then you find b. So like these numbers all relate and connect somehow.
Yeah, I mean, yes and no, I would say. I mean, from a usage point of view, no denying that. This is going to be a foundation block for us to deal with trigonometry and geometry to some extent. But you guys are much more nicer than me. I'm not that nice when it comes to believing somebody. So now let's keep the jokes aside. Here, this theorem is based on a concept called similarity of triangles. If you have two triangles similar to each other, if these two triangles are similar to each other, meaning angle 1 has a corresponding angle matching here in the second triangle, angle 2 has a corresponding matching angle here, and angle 3 has a corresponding matching angle here. Okay? Then these two are similar, meaning the angles are same. These triangles, every angle has a corresponding matching angle in the second triangle. So if you guys, I mean, everybody uses phone. So when you look at zoom in, zoom out, okay? If you have a small triangle and you zoom in, let's say we all zoom in into our faces, right? When you take a picture, am I looking good? Is my eyes closed? Whatever, right? In the picture. So think of a triangle in the picture, and I will show you guys something that might not look perfect, but I have a triangle right now here. If I'm zooming in, what I'm doing, I'm just making the size bigger, but the angles don't change. So zoom in, zoom out is the right example of similarity of triangle if you're talking about a triangle. Okay? Meaning your angles are remaining the same, only the sides are scaling up or scaling down based on whether you're zooming in or zooming out. Does it make sense, or I'm just talking through thin air? Making sense? Yeah. Zoom in, zoom out is a classic example. Now, similarity of triangles says that if you have two triangles similar, then their sides will be in the same proportion.
let's say this is 1, this is A, this is B, and this is small b, this is capital C, this is small c. So when you have two triangles similar, then their sides A is to A will be equal to B is to B will be equal to C is to C.
Okay? Okay? And this is the basic, scaling of triangles that we can talk about. So if you have two triangles similar, then their sides will be in the same ratio. Okay? Because if you are increasing, let's say you are zooming in by 2x, you are increasing each side by 2 times the dimension. So that's what it means. Now this whole Pythagorean theorem is based on this concept of similarity of triangles. I'm not going to prove this one right now, and if you guys want me to prove that, I can do it. I love doing it. But I'll just give you guys a glimpse of it.
Am I boring anybody so far? Anybody who is thinking that this guy comes into our life every Saturday and Sunday and steals 2 hours?
Cracking dad jokes. Anybody bored so far? No? Even if you are bored, you will not say yes, right? Okay, anyways, let's move on.
Okay.
This is a right angle triangle I have.
And this is A, and this is B, and this is C, and somebody has forced you to believe that A square plus B square equal to C square.
Okay? Yeah? Now, we don't want to believe this, we would want to see why.
So let's look at it. What I'll do is, I'll drop a perpendicular from here to here. Let me give it a name. Okay. I will say this is L, this is M, and this is N. This is M and this is N. My N is the hypotenuse of the original triangle.
Okay? This is my triangle, right angle triangle ABC, and this angle is 90 degree. What I have done is, from this vertex, I have dropped a perpendicular to the other side. Okay?
Now what I have done is, let's say this is meeting at point B. So earlier we had a triangle ABC, this was a right angle triangle. Now by dropping a perpendicular from here to here, we have got two baby triangles. One is ABD and other baby triangle is this one. So let me color it for you guys. One is this blue triangle that you are seeing here, and that blue triangle is BCD. Okay, since this is a blue triangle, just to stay color compliant,
I have colored it blue.
and then you have a green triangle, that is this one. This green triangle is this ABB.
Yeah? Everybody is okay to relate to what I'm saying? So we have a triangle ABC. From this corner where I'm making 90 degree, I've dropped a perpendicular onto the opposite side, and it meets the opposite side at point D. So the earlier triangle ABC is split into two baby triangles. One is the green one, which is ABD, and the other one is the blue one, which is BCD. So far okay? Yeah? Khushi, Samriddhi, Ananya, Neil, Sarah, Ritika, everybody okay? Sriyan okay? Okay. Jenna also okay? Jenna is very nice. Jenna said that this one I will believe, and I'm forcing her to not to be nice. Okay? Alright. So now what I'm saying is these two triangles ABD and triangle ABC. I'm saying these two are similar triangles. These two are similar. Meaning ABD is the green one. ABD is the green one, okay? Look at this picture carefully. I'm saying this triangle, the green one, and the parent triangle, the larger one. These are similar. Is it worth believing? This small green triangle and the large triangle, I'm saying these are similar. Jenna says yes. And I'm trying to make sure everybody is convinced. See, in this large triangle and this baby triangle, large triangle and the baby triangle, this angle is anyways common. So one angle is common.
Okay. Now you're looking at, so let me put the names to it. BAC, and here angle again BAC. This angle is common in which way, whether the small triangle or the large triangle. This angle is common. Okay. And second one is, if I'm looking at ABD, the green one, ABD, angle ADB equal to angle ABC equal to 90 degree. I'm looking at the small triangle ADB. This angle is 90 degree because I have dropped a perpendicular from here to here. So this angle is 90 degree, and when I'm comparing this with the larger triangle ABC, this ABC is again this 90 degree because it's a right angle triangle. So I have, between the two triangles, I have two angles which are matching. Does the third angle have a choice of not matching? Any triangle that you pick up, sum of all the three angles is 180 degree. And two of the angles have matched. Third angle for both the triangle will be 180 degree minus sum of angle 1 plus angle 2. This is angle 1, this is angle 1, this is angle 2. Your third angle for both the triangles would be 180 minus sum of these two angles, isn't it? Siddharth is trying to believe me. No, it's okay. Don't say yes unless you are convinced. Yeah? So, again, look at the small triangle, the green one and the large triangle. This angle is common in both the triangles, be it the small triangle or the large triangle. This angle is common. Now you are looking at the small triangle. See, this is the line that is splitting both the triangles. Okay. This side I am talking about all the angles for this one, and this side I am talking about all the angles for the large triangle. This green one is common in both of them. Okay, this angle. Second angle, now if I look at the large triangle, second angle is this one, which is 90 degree, ABC. ABC. And when I look at the same small triangle, this is the 90 degree, meaning ADB. So two of the angles have matched between the two triangles. Yeah? Or look at it this way. Let me take this ADB as a separate triangle. I will write it. B, this is B, this is D, and this is A. What I've done is, I took this triangle from here and I flipped it so that it looks like a right angle triangle. This larger triangle, this triangle I took it and flipped it by 90 degree. So this is my BDA, green triangle, and this is the large ABC triangle. Angle BAC is here, and in this case it's here, but both are common here, same. Okay. So one angle is matching and second angle is 90 degree. Third angle has to be 90 degree, 180 degree minus 90 plus the matching angle. So if you have two triangles where two angles are matching, third angle will match because third angle will be 180 minus the sum of the remaining two angles. Yeah? Is everyone with me, or I'm just going too much in air? Tony with me? Vivan with me? Ritika, okay to believe me? Okay, alright. So basically from this what we found was this small triangle is similar to the large triangle. And this small triangle is nothing but when I am dropping a perpendicular from here to here. Same way, this small triangle is also going to be similar to the large triangle, again, because they have matching angles. This angle is common. There is a 90 degree here, there is 90 degree in the large one. So basically, this small triangle and this small triangle both are similar to the large triangle. Okay, and when the triangles are similar, their sides will be the same ratio. Okay, So here, when you're looking at this combination, let's say when you're looking at this combination, what you will find is ABD, this green one. Here, this is the matching angle. This is the same angle. So let's pick the small one. Side opposite to that is what? BD. BD over the large triangles matching is the same, but the side opposite to that is BC. BD by BC will be equal to, let's take the other matching angle. So this is 90 degree. So side opposite to that is this one, AB. And this 90 degree, side opposite to that is AC. Okay. So you got BD by BC equal to AB by AC. Okay. Now, and then the third angle is which one? Third angle is this one. Side opposite to that is AD. And angle matching to this one is this one in the large triangle. So it will be AB. So here, whatever I'm doing nothing fancy. I'm just saying that we had a right angle triangle. From the corner where it's making 90 degree, I dropped a perpendicular on the opposite side, which splits this into two right angle baby triangles. And what we are seeing is this baby triangle is similar to the large triangle. This baby triangle is similar to this large triangle. Okay? And when they are similar, the concept of similarity says when you have two triangles similar, their sides will be in the same ratio. So in the numerator, I am keeping all the sides for the small triangle, this green one, and this is the ratio I got. And in the denominator, I have the sides corresponding to the matching angle for the larger triangle. Yeah. So from this one, if I pick this combination, because here I have AB at the bottom, AB here, I'll do a cross here. So AB by AC is equal to AD by AB. And again, this might look a little cryptic. That is where you will have to probably do that scrapbook yourself, okay, and then get that confidence with which I'm doing it right now. Okay, it might sound just by me uttering some words would not make much sense to you. So you'll have to just do it. I'm just giving you as a clue that okay, pick up a triangle, drop a perpendicular from here to here. It splits into two right angle triangles. This small triangle is similar to this one. This small triangle is similar to this one again. And then similarity says that okay, their sides will be in the same proportion. So I picked up this combination, the green and the large combination. And from that I got AB into AB. I'll do a cross. So AB square equal to AC into AD. Okay. So this is one thing that we have derived. Okay. Now let's go to the second combination. Second combination of the triangles, if you see, which is BCD. So BCD. Okay. This is the blue one. So I'll use the blue marker. So BCD. I'm looking at the blue one right now. This one is also similar to the large triangle because this angle is common. Other angle is 90 degree matching with the other one. So third angle will match. Now I'm doing the ratio from that also. So I'm BCD. This is a small one. So this angle is common. So it will be BD, side opposite to that angle, BD with a small triangle, divided by side opposite to this in the larger triangle will be AB. This ratio will be equal to, now let's look at the second matching angle. So this is 90 degree, side opposite to that is BC. BC and in the large triangle, what is the 90 degree angle? This one, side opposite to that is AC. Okay. And then the third angle is this one which matches with this one. So side opposite to this in the small triangle is CD, and then this is the matching angle in the larger triangle, side opposite to that is BC. So here again you take the same combination BC, BC. Okay. So from this one, BC by AC equal to CD by BC. And then you do a cross, what you get is BC square, BC into BC will give you BC square equal to AC into CD. And now you guys must be thinking that
what is going on here? So confusing. Nothing. Again, right triangle, dropped a perpendicular, found two similar, this triangle similar to large one, this triangle similar to large one, and from that we have found out the ratio, and we are picking up a combination where I can do a square, because we have to find out whether this square plus this square equal to this square or not, or this small square, and this is A and this is B and this is C, this square plus this square equal to this square or not. Now you have two equations. Let me put those equations together and then we will see. So the first one says AB square equal to AC into AD, and second one says BC square equal to AC into CD. Okay? Okay? Now, what is this AB square? AB is this square. And what is this BC square? This is this length side B square. So from this what we can say, if you add these two together, it became AB square plus BC square equals AC into AD plus AC into CD. Here AC is common. So if I go to the next page, AB plus AB square plus BC square equals, here AC is common, take AC common out, AD plus CD, AD plus CD, which is nothing but here this whole length. So this became AC into AD plus CD. AD plus CD is nothing but this whole side AC, which you got as AC square. Now you see AB square plus BC square equal to AC square. So A square plus B square equal to C square. I know this is not a math that you would understand easily, and I don't have a better, easier way to explain this. But summary of this whole thing is that the Pythagorean theorem is based on the concept of similarity of triangles. It is not a theorem that is given to us in air saying that okay, no matter what, you have to believe it. So, and we just tried exploiting that concept of similarity of triangle, which says if you have two triangles similar, their sides will be in the same proportion. We took a right angle triangle, dropped a perpendicular, and we found that okay, these two baby triangles are similar to the original triangle, the larger one. So based on that, we put the ratios and then we took a combination so that we can add them together to prove this theorem. I can guarantee that nobody will ever ask you to prove a Pythagorean theorem. Okay? And everybody has accepted that as a rule of thumb. But then in this class, if I ever tell you guys that this is a theorem, memorize it, I'll be committing a crime. Okay? That's why I always try to explain how that thing came into existence so that you are conceptually aware of it. At least after today's class, whether you are able to prove this theorem or not by yourself, you'll be 100% sure that okay, Pythagorean theorem is not given to us to memorize. It is based on the concept of similarity of triangles. Does that make sense? Or no? Kushi, Neil, Sarah, Ananya, Sri, and everybody. Did I make some sense, or I'm getting you guys actually worried? Ananya is convinced. How about Kushi? Okay, beta? Yeah. So again, what I'm guiding you guys towards is that if I ever tell you any theorem, any concept, please don't have any fear or hesitation to say, okay, sir, can you tell us how it is, why it is to be believed? Because math, I teach math for a reason. Because this is the only subject where there is no opportunity for assumption. Anything and everything that we do can be written in stone if we are clear about the concepts. Yeah? Saranya, okay, beta? Ritika? Everybody, Yasmita? Okay. Alright. So, this is the core of Pythagorean theorem.
Vishal, did I tell you, did I explain this to you before in any other class? I think I did, right? Or Dave? There are some kids who have been tortured with me for a little longer time, so that's why I'm asking them.
Yeah, okay, I had explained that. But again, if you have learned something and if we are doing it again, it just reaffirms our understanding is right, okay? We are not wasting time by learning something over and over again. Okay? It will just stay with you a little longer. Somebody in my neighborhood got a great idea of running the lawnmower when we are having the class, but I hope you guys can hear me okay. Okay, wonderful. So we looked at Pythagorean theorem. Now let's look at the application of it, which I'm pretty sure you guys know about it. If I have a right triangle, let's say this is 4, this is 3 centimeter, and this is 4 centimeter. And somebody says find out the length of the hypotenuse. This is the right angle triangle. This is 90 degrees. You can apply Pythagorean theorem and find it, right? A square plus b square, meaning the two sides that is making 90 degrees, square of that 4 square plus 3 square will be equal to, let's say this is x, so x square. Yeah? Everybody knows about it? So 4 square is nothing but 16, 3 square is nothing but 9, equal to x square. So x square equal to 16 plus 9, 25, or x will be equal to square root of 25, which will be 5. Yeah? This is the application part of it that you guys know. What is Pythagorean triples actually? Anybody? Have you heard about it? Tell me what exactly it is beyond.
So, well, the two I don't have my you know some numbers in the square, the equals, a square plus b square equals c square. There's some numbers which are like defined like that. So for example, like 3, 4, 5, 5, 12, 13, and 7, 24, 5. Like they're all very fixed and they're all very popular.
Right. So, like what Divan said, that is the right description of it. Let's say I have, let's pick 3 combinations, okay? 3, 4, 5. So 3 square plus 4 square equal to 5 square, okay? 3 square is 9, 4 square is 16, 9 plus 6, 25, which is equal to 5 square. 5, 12, 13. So 5 square plus 12 square. So 5 square is 25, 12 square is 144, which equals 169. And 169 is nothing but square of 30. Yep. And what is the third one we want? 7, 24, 25. That's the one?
Yeah.
Let's check that also. So 7 square plus 24 square. 7 square is 49, 24 square will be 24 square. 24 4 is 96, 48 plus 9, 57. So 576. And so this is, so let me first check if I did it right. 24 4 is 96. 9 carries 24 to the 48 plus 9, which is 576. Yeah, this looks okay. When you add these two together, this became 6 plus 9 is 5, 15, 1 carry forward, 4 plus 7, 11, plus 1, 12, 1 carry forward, 5 plus 1, 6. And this is nothing but 25 square. So 25 to 25 if you do, 25 5 the 125, 12 carry forward, 12 5 to the 50 plus 12, 62. Yeah. Yes, Vivan.
But sir, is it true that the Pythagorean theorem, like the Pythagorean triples, they always have to be like the simplest
Not really. Not really. Now the next thing that I'm going to disclose is this. So we saw 3 combinations, okay? 3, 4, 5, 5, 12, 13, 7, 24, 25 like Vivan said. These are called Pythagorean triplets or triples. Meaning, if you have any this is a combination that you'll come across very often in the exam. You'll say, okay, this side is 4, hypotenuse is 5, find out the other side. This is part of Pythagorean triples. Okay? There are 3 combinations. Now, what it means to us is, if you multiply this whole thing, 3, 4 and 5 by 2, so 6, 4 2 is 8, 5 2 is 10. This is also another triple. If you multiply this combination by 5, so 5 3 is 15, 5 4 is 20, 5 5 is 25. This is another combination. If you want to check this, let's check this one. 6 6 is 36, 8 8 is 64, adds up to 100, which is nothing but 10 square. Okay? So if you have any combination, okay, and you see that there is a common factor that you can take out. See, we saw these 3 triples, right? And there will be more combinations. We are not going deeper into it. But 3, 4, 5, 5, 12, 13 and 7, 24, 25. Tomorrow somebody says that I have 14, 48 and 50 as 3 sides. Or somebody says, okay, 14, 48. I have a right angle triangle. One side is 14, other side is 48. What is the third side? Obviously, you can do you can apply Pythagorean theorem and do it, or else you are clearly seeing that this is an even number. This is also even number. This becomes 7 and this becomes 24. If you divide both of them by 2, oh, 7, 24, 25 is a combination. So third side will be 25, and to make it a triple, I have to multiply this also by 2 so that it matches with this combination. So this we are talking about 50 here. So this will be more like a mind map that you can do to find it out very quickly. Otherwise, obviously, you can apply the Pythagorean theorem to solve it. So to your point, Vivan, Pythagorean triples are in the simplest form, but you can multiply each combination by a certain number, and that will also represent a Pythagorean theorem. I mean, that will also represent a right angle triangle. So that is nothing but a zoomed in version of the same triangle. Yeah? Khushi, Nanya, are you guys with me? I mean, being with me means, is it making sense to everybody, okay? I don't make sense all the time. I get confused more often than me making sense. So, I'm just checking. Siddharth, okay? Tony, okay? Saranya, okay? Jana? See, your likes don't count, but it matters to me. Okay? If the kids are comfortable with whatever we are talking about, that's my takeaway. Alright, so we looked at what is Pythagorean theorem and what is Pythagorean triples. So basically it is just an offshoot of the Pythagorean theorem. Okay? It says, okay, there are some very commonly used combinations that gives you a quick calculation method. Okay? So if it's a right angle triangle, there is a relationship between the sides and the hypotenuse, right? That's what Pythagorean theorem talks about, correct? So, what are the commonly used combinations? That's what is given a name, Pythagorean triples. That's it, nothing more. Yeah? And how it helps us is, you can always think of these combinations being multiplied or divided by a common number, and that also represents a right triangle. Similar right triangle. Meaning a toned down or toned up version of the same triangle. Yes, Rian.
So are the 3 combinations given the only Pythagorean triple?
No, there could be more.
Okay, got it.
There could be more. We can. Best source of that would be. I mean, there are 3 that comes to my mind. In fact, thanks to Vivan, he gave me this combination also. I have these 2 in my mind. Okay, I mean, since I'm very poor when it comes to memorizing things,
So these two I memorized, remember based on my acquaintance. When Vivan gave this combination also, we checked and we found that is also a combination. So likewise there could be more.
Okay. And you can identify a Pythagorean triple if like three numbers given have like a common factor. Is that like, so that's when it classifies as like a Pythagorean triple?
Yeah, that also. So not really. There's no common factor here. 3, 4, 5, nothing. That doesn't have any common factor. But if you multiply this whole thing by 2 or 3 or 5 or 6, that also would be a Pythagorean theorem. So if you find out the common factor and then what you are left with is falling into any of these combinations, then that gives you a confirmation that okay, this is also part of the Pythagorean triple.
Okay.
Yeah. Everybody with me so far? Tony, okay? All right. So now Vishal and Dave have been very quiet. Is it because we have dealt with it a lot already? Samriddhi, Sarah, Neil, everybody okay? Ritika okay?
Yes, sir.
Okay, all right. So let's move on to the next thing that we wanted to cover. Okay. So let's go to the next thing that we wanted to cover as part of the class this week. Now comes the next concept that you guys would be knowing about. Okay, Vishal, no problem. But as long as you can hear me and you can see what circus and drama I'm doing on the board, you're fine. Okay? So now Siddharth is thinking that I came for math class, why I'm being forced to watch circus and drama. No choice. But whatever we have discussed so far, everybody is with me, right? Now the next thing is trigonometric ratios. What do we mean by that? Anybody? And give me very simple definition, because I have one problem, one health issue called short-term memory loss, which I come across very often. So you guys have to help me memorize or remind me of that concept. So right now I'm dealing with short-term memory loss, and I don't know what is meant by trigonometric ratios. Can somebody help me recall that? Kusi has been in the class for very little time and she's thinking, where did I get trapped? My teacher has this health condition of short-term memory loss. Now, I'm just kidding. I'm just giving you guys a chance to describe or help me recollect what exactly it is.
Are we doing like cosine, sine,
Sine, cosine and tangent. Yep. So that's what is trigonometric ratios, trig ratios. Sometimes people call it trig identities also. Okay. So and that is just the extension of geometry. And you guys will think that okay, yet we are talking about trigonometry, and how come it is extension of geometry? Now a more serious or intense question to you all is, why do we even need trig ratios? Let's say Pythagorean theorem has said that if you know two sides, this side and this side, you can find this side. Or if you know this side and this side, you can find out this side by using Pythagorean theorem. Okay. Now we are talking about trig ratios. So sine, cos, cosine, tan, and then reverse of sine is cosec, reverse of cos is sec, and reverse of tan is cot. Yeah. So these are called trig ratios, and they are called ratios because it talks about the ratio of the sides. Now if you look at this whole thing is represented by the most hated acronym SOHCAHTOA. Yeah. Not heard it? Wonderful. That makes me happy. That I'm teaching something for somebody's benefit. Anybody in the class who has not come across SOHCAHTOA? And it's okay. It's just for my information. Like I always say that I'm the worst teacher. So I have no shame in saying so there's something that I don't know. So I want all my kids, meaning all of you all are my kids, okay? I want all of you to be equally brave. If you don't know something, just say, I don't know it. That's okay. We'll learn it. Nothing is falling apart. Yeah? Anyone in the class who is not aware of what is Sokatoa? So I'm assuming everybody is aware of it. Tony, clear? Okay. I'll still repeat it. Sokatoa is a short form for representing trig ratios or acronym for trig ratios. Like so, S stands for sine, O stands for opposite side, H stands for hypotenuse, C stands for cosine, A stands for adjacent side, H for hypotenuse, T stands for tangent, O for opposite side, A for adjacent side. Now you'll say, what is that we're talking about? Let's pick this angle. We don't know what this angle is. We are giving it a name theta. So sine of this theta will go by this. Sine of this theta will be opposite side. So what is the opposite side to this angle? A. A over, let's say PQM, okay? Because A, B, C might get you confused. PQM. I'm just giving you different names, that's all. Sine of an angle is equal to opposite side divided by hypotenuse. So sine of this angle is opposite side. This is P divided by hypotenuse. My hypotenuse is M. Cosine of the angle is equal to adjacent side. So this is the angle, this is the opposite side, this is the adjacent side. It will be Q adjacent side divided by hypotenuse by M. 2R stands for tangent. So tangent of a side is opposite side divided by adjacent side. Opposite side to this is P divided by adjacent side, which is Q. Everybody with me so far? So that's okay? So Sokatoa is nothing but your acronym for relating to these values, okay? Now reverse of sine is cosec. So sine is P by M, so cosec will be equal to M by P. This just flips upside down. Cosine is Q by M from this triangle. So you don't have to remember PQM here, okay? You have to just remember this because the name of the sides and the length of the sides could be different, okay? Sine is opposite side by hypotenuse, cosine is adjacent side by hypotenuse, tangent is opposite side by adjacent side. Cosec will be reverse of sine. So it's P by M, it will become M by P. Sec is reverse of cosine. So it's Q by M, it will become M by Q. Cot is reverse of tan, Q by P. Yep. Is that okay? There's another relationship that you would see from here is sine over cos is nothing but tan. Sine theta divided by cosine theta is equal to tan theta. And you don't have to memorize this. You can see it from here. What is your sine? Sine is P by M divided by cosine. Cosine is Q by M. So this becomes P by M into M by Q. I'm just doing fraction multiplication. Okay? This M and this M I can do tic-tac-toe, P by Q. This is what we saw as tan theta. So sine theta by cos theta equal to tan theta. And you're not believing me just because I said so. We just saw it happening. Yeah? Is everybody with me? Now the next concept that we'll talk about is the concept of complementary angles. But before we go there, okay, let's spend a couple of minutes here. I'm kind of getting you guys little tortured right now. And I'm kind of forcing you guys to believe something, do something. You guys have learned algebra, you guys have learned basic arithmetics, you have learned geometry, you dealt with linear equation, quadratic equation, whatnot. Now I'm introducing another thing called trigonometry. I mean, it's not me who is the culprit alone. Your syllabus also has this in the concept. But before we learn anything new, we should convince ourselves that why do we need to learn trigonometry? Yeah. So, Yasmita, Khushi, Sriyan, Vishal, anybody, Dev, tell me why do we need to learn trigonometry actually? What is the compulsion we have for learning this subject? And you guys can be as creative as possible, okay? It's okay, think about it. Let's say, let me give you guys a very lame example. Let's say if I have electricity connection from CoServe, let's say, okay? Somebody is selling other electricity connection. I already have electricity connection. Why do I need another one? I'm getting lights in my bulb, power to my devices, power to my TV, everything. Why do I need to buy another electricity connection? There has to be some motivation, right? Unless that guy say, okay, I'll give you for half the price. I'll give you a lot more advantages or benefits along with it. That becomes a motivation for us. So likewise, I'm telling you guys that, okay, you have a right angle triangle, you have Pythagorean theorem to find out the property. I mean, every shape that we talk about ultimately boils down to finding out more details about it. So we had Pythagorean theorem that was good enough for us to find out the property of the sides and all that. Okay, we knew about similarity concepts also. So we can deal with angles also to a little bit. But why do we need to learn trigonometry is what I'm wanting to hear from you guys. Be creative. Jenna is trying to say something, but I'm not able to hear anything.
Oh, I don't know. My mic is just on.
You guys are not being creative. Give it a try. And this class is free for all. Make mistakes. I love mistakes. Ananya, any thoughts, beta? Khushi? Sarah, Neil, anything? I'm asking you guys to convince me, why do we need to learn trigonometry?
It's about triangles. I don't really understand it too much.
Okay. Rians, you are 5 minutes early for the class. John, to 4 minutes. Okay. Yes, Jenna, give it a try.
Okay, I think we have to learn geometry because geometry can be used in basically everything if you really think about it.
Mm-hmm.
Like, say if you're building something, you have to use geometry to find the height of it or the area.
Mm-hmm.
Or if you're building a bridge or something, you need to use geometry to find the measurements. That's my.
Okay. So let me, just because we are running against time, so let me give you guys some background to it. Now if you look at geometry, in geometry what we know? We know sides. If we know two sides, we can find the third side. If I talk about right angle triangle right now, okay? But the relationship between the angle and the side is not known. If you know these two sides, you can find the third side. If you know these two sides, you can find this one. That is fine. But this angle also matters. This right angle triangle is way different from this right angle triangle. And what is defining that is the angle between the sides. Sit in that corner before your class starts, okay? So, the angles and the sides, see, if you're looking at a triangle, there are two key things, the sides and the angles between them. And the relationship between the angles and side is what is not known only by geometry. If you know the sides, you can find the angles. Or you know the angles, you cannot find the sides. Sit down. Just don't listen to what I'm doing for next 2-3 minutes. Your class will start in 2-3 minutes. Nikhil, sit down. Okay? So, Trigonometry works as a bridge between sides and angles, okay? The relationship between the sides and angles you can find out. Anika, if you move a little bit, Nikhil can also sit next to you. Okay? So trigonometry works as a bridge between angles and sides and it helps you relate to them. Come and sit in the corner.
Are we gonna have the 45?
1 hour class. 1 hour.
Okay, then my dad's gonna come and pick me up 5 minutes early.
Like always.
Yeah, 1 minute.
So basically, trigonometry works as a bridge between the sides and angles. It establishes the relationship between the sides and the angles. And we'll deal with that in the coming class. And that will probably clear a little more dust from where we are right now. But whatever we learned today, quick recap of that is, we talked about Pythagorean theorem, what is the source of Pythagorean theorem, how is that proved, and then we looked at Pythagorean triples, and we were trying to establish the relationship between sides and angles, and what is the origin of trigonometry, why do we need trigonometry itself. I know it might not have sounded very productive to all of you because nobody talks about why trigonometry. We are doing that because next time when we deal with trigonometry, it will be easy for us to relate and then deal with it. Okay? With that being said, I'll let you guys go unless somebody has a question for me for the last 1 minute.
Sir.
No, your class is not